ready to start. And thanks to everyone to be here. Good morning, good afternoon, wherever you are. So let's to start with this 11th M4DT as Metrology for Digital Transformation Day. With the topic today is Metrology for Industry 4.0. My name is Gabriel Lugo. I'm a project leader from Senam, and as well I collaborate as a co-coordinator with Marcos Biersi-Chudek from INTI in the task force Metrology for Industry 4.0 of the Metrology Working Group 14 of the Inter-American Metrology System. And today, I will be the host for this event. Before we start, I would like to share with you important information and some specific guidelines. First of all, the event will be recorded from the beginning until the end. And the second, please, your microphones and cameras must be turned off unless you are asked specifically. Otherwise, you can use the chat to ask any question anytime, please, to the speaker at any time, but they will be answered as soon as the speaker ends the presentation. The duration, the length of each presentation will be of 25 minutes. And after the time for questions will be open. Right after the end of the event, a short survey about today's experience will appear. Please, it will take a time for us. It's important your feedback to improve our work in the next events. This workshop, as I said, is organized by the Metrology Working Group 14 of the Inter-American Metrology System, or SIM in Spanish, and our objective with these events is to promote the digital transformation in the region and make lessons with the similar organizations. Feel welcome, everyone here. The Metrology Working Group is the link between the SIM Metrology Working Group and the digital transformation. The Metrology Working Group has 6 task forces to specifically work in different subjects that interest the region. I invite you to participate in all of them. The contact of the groups will be shown in the chat box. I have to thank our colleagues that are supporting for this transmission, and feel free to interrupt me, colleagues, if I can't see the chat. So feel free to interrupt me anytime. Also, I would like to check our website. I would like to check our website where you may find information to task forces, activities, and other events. Also, you may find videos and several presentations. The web page will be also appear in the chat. The web page of the team and the web page of this Metrology Working Group 14. For starting with this event, we will start with the first presentation of the day, and this is the topic is Metrology for IoT applications. The presentation will also appear in the chat. Olman Ramos from LCN, Laboratorio Costarricense de Metrología. Olman Ramos is a mechanical engineer with a master's degree in mechanical engineering and manufacturing systems and materials from the University of Costa Rica. He works as head of the Department of Physical Metrology and has developed his metrological activities in the Laboratory of Mass and Scales of the LCM. He's a professor in the master's degree in mechanical engineering at the University of Costa Rica in the class of measurements and instrumentation. He's an instructor at the LCM on topics of metrology and digitalization, coordinator of the LCM digitalization and metrology 4.0 working group created in August 2019, representative of the Costa Rica Metrology Laboratory at SIM Working Group 14. He's a member of the IMECO TC6 in digital transformation, and as well he's part of this task force of metrology for Industry 4.0. Welcome, Olman. Please, the floor is yours, and feel free. I have to share with you that all our colleagues. Most of them we are a native Spanish language, so we are trying to do our best speaking English. So feel free if you don't understand something, or if you can ask your question in Spanish or in English. So thank you very much and welcome, Orman. The floor is yours.
Thank you, Don Juan. Thank you so much. I need to know if you see my presentation right now.
Yes, we see it.
Yes. Okay, excellent. Today, we will discuss a little bit about a very important situation that happened in most of the National Metrology Institute. Because the digitalization is very important, and all the situations around the digitalization are new for all the National Metrology Institute, especially for the Same Metrology Institute. So we try to expose to you some two different situations that we try to resolve right now here inside the Laboratorio Costarricense of Metrology. First of all, the Costa Rica Metrology Laboratory is the National Metrology Laboratory, and it was created by law. The number of the law is 8279. Is the law of the National System of Quality. Our structure is like this one, like you see right here. We have 4 departments, 3 technical departments. The first one is the chemical department. The next one is the legal department, and I am working in the physical department. I am the chief of the physical department. So the digitalization and all the experience around is working all these 3 technical departments. We will discuss one situation that happened, and I was present as that in the meeting of digitalization and Metrology 4.0 experience around is working all these 3 technical departments. Some situations that was special for us. We will discuss start for the one situation that happened for Industrial Revolution and the Interconnected Industry 4.0. I don't speak about history, but it's important because in all the presentations, all the people speak about the revolution, the Industrial Revolution, but it's important to try to explain here the origin of this situation that happens. The function of the experimental, the definition of the Industrial Revolution is this one: the function of experimental technologies that disintegrate the boards between the physical, digital, and biological areas for the development of fully interconnected and automated industry. This is the 4th Industrial Revolution and was present for Klaus Schwab in the economy forum, the World Economic Forum in 2017. This Industrial Revolution is composed of 4 important parts. First, the instantaneously, in Spanish is instantaneidad, is monitoring and analyze the data in real time. The virtualization, remote and virtual monitoring of production process. Decentralization in decision making. Cyber physical system that make decision based in data analysis. Modularization, the system is divided into modules and produced according to demand. This means you can have an industry that is intelligent inside. So this industry make all the process, control all the process, and take the decision inside the moment or in real time. This is the base of the fourth revolution. Around this fourth revolution, we have some new technologies. These new technologies are destined to perform all the changes. And one of these new technologies is obviously the Internet of Things, is the first one, and the industry Internet of Things. This is the topic that we will study today. But the other technologies are very important too, because are interrelated with this, are interrelated in between. For example, storage and use of information in cloud, big data, cybersecurity, secure blockchain, autonomous robotic and artificial intelligence, image analyzing, analysis of and processing of biometric data, system of production, storage and use of energy, drones, virtual reality, 3D printers, etc. But what is IoT? The IoT is the Internet of Things. The term is or explain the process that allows connecting day by day physical elements through internet network, and it also refers to the technology that facilitates communication between these devices and the cloud, as well as between the devices themselves very safely, so with security of the data, to work correctly without a human intervention. In this case, we are talking about the traditional Internet of Things. So this red is the Internet of Things that it permits to the human to introduce new references, new things, new elements, and get information and take decisions. These decisions are taken by analysis of data, amount, a little big quantity of data, and making an analysis of this information using algorithms or intelligent artificial intelligence. The IoT network is possible to find day-by-day devices. In the IoT network, it is possible to find day-by-day devices and artifacts from home, office, monitoring the state of the human health or animal health, devices for controlling the state of energy supply, water, gas, transport, vehicles, or of kind, containers and parcels, telecommunications, among of many others. You can see the reference for this IoT information here, and you can consult if you are interested to see this information. But the topic that we will discuss here is the industrial Internet of Things. The industrial Internet of Things is very similar to the Internet of Things that we know or we experiment day by day. But in this case, it's important to know that the industrial Internet of Things is created for a special and unique situation inside the plant, inside the industry, or inside the manufacturing area. So we have some artifacts, sensors, or different dispositive. No, sorry, I tried to confuse a word in Spanish. Some artifacts and sensors that give us information to take some decisions. This network or sensor is, in some cases, complete for all the installation for the plant, or is dedicated to an independent area. But the most important here is the possibility to take some decisions in real time, in the moment, if something happened. and have some advantages for the production. What advantages are talking about? Well, okay, the result is a reduction of maintenance cost, an increase in the useful life of equipment, machines and control and telecommunication systems, safer environments, reduction in production errors, reduction in rework, use of raw materials, efficiency in the logistic of production, and in the transportation and storage of products and parts. How do we apply or how we use this IIoT, Industrial of Internet of Things, in real life? We have two cases that we confront inside the LCM here in Costa Rica. First, we need to discuss the definition of Metrology 4.0, because the most important is to remember that we are a metrologist. We're working in the National Metrology Institute. So we work in the metrology. So the idea is to provide our best capabilities to the industry, and our best capabilities are exactly the metrology. So first, the Metrology 4.0 is more than a definition, it's a concept where the science of measurements intervenes to propose adequate parameters for the correct representation of the information associated and traceable to the international system of units, including methods, tools, representation, and expression of the quantities, units, measurement errors, and measurement uncertainties, so that the data and metadata are understandable and usable by machines. It has to do with syntax, semantics, taxonomy, controlled vocabulary, ontologies, and every aspect that characterizes and gives a digital meaning to the data and metadata associated with a measurement. So with this definition, we can know how we can collaborate with the industry from our area of work. This is the same definition, that only different is in Spanish. In our case, in LCM here in Costa Rica, we developed two processes where metrology worked to ensure and validate the data provided by network of sensors. And the first one was work in two different times. We work with a special industry. We link this industry between or using our industry linkages strategy, the ABI, allowed to intervene between the LCM and an Narime company. The Narime company was selected because they present a problem to us, and when we discuss the situation with, we know that it was a very big opportunity to work with them. In 2020, we decided to calibrate some sensors for the network of Narime. Narime is an industry that work in the small company and work in the agriculture area, in the industrial agriculture area. So they provide information to the agricultors in the production in all the year. In 2020, we calibrate some sensors, hygrothermometers, one sensor for measure the quantity of rain. In that moment, they need some calibration or more calibration. But we discovered that we can make this calibration because we don't have the complete capability for make that calibrations. In 2022,
Tu está participando da reunião
In 2022, we calibrate again this sensor, but we include a new sensor, a special, more exactly sensor that was used like a standard for this to this network of sensors. The second situation was or is, because we are working with this right now, is the participation in the BIT CIM development of a thermobarometer with digitalization criteria project. Has involved in this case the LCM decide to calibrate some sensor because we need to know if in this project this sensor can be used like a reference or like a good sensor for construct or create a real artifact for the project. So in this case, we include these sensors inside our calibration chronogram. For the first experience here with the industry, Narime. Narime is a company that seeks to integrate the knowledge of different technologies, technological area, Internet of Things, big data, artificial intelligence, and sensor network, and agronomics to improve the current influence models of the agriculture sector. Thus ensuring that an activity as important as agriculture works in hand with new technology trends. Currently, there is a data collectors or collection and information interpretation system that provides irrigation recommendation for farmers to obtain more productive and healthy harvests and optimize the consumption of water resources. The important topic here all is the use of a real or a special quantity of water. How this network works? First, the sensors of the IoT devices are calibrated in the national laboratory, in this case is us. So they come with this sensors to our labs, and we give the calibration to these sensors, and they use these sensors to improve or to create a network for a special area. A meteorological station is placed to monitor environmental variables, temperature, humidity, radiation, precipitation, and wind speed, and a network of unit modules to monitor soil variables, moisture, or soil absorption. The data collected by the system is sent and stored in a database in the cloud. The algorithm use data of the environmental, soil, terrain, type of crop, and type of irrigation system to estimate the irrigation time corresponding to each crop block. This irrigation recommendation is provided to farmers through an app. So the farmers has information in real time, so they can take some decisions with this information in real time. The second situation was the calibration, the second topic was the calibration of the sensor for the IDB project. In this case, we create the sensor using a BME280 with an Arduino. So we dispose or create a dispositive or artifact with the Arduino. We program the Arduino with the sensor and put this sensor inside a chamber for humidity or humid chamber, and a pressure chamber. The reference for the humidity calibration was the Rutronic, and for the pressure was the RPM4. In this case, we have some information from the calibration, and the idea is to take a decision if this sensor could good or will be good to use in the project for create the artifact. So these are two cases that we explored for IOOT for Industry 4.0, because one of the most important things here is that the industry needs to calibrate the sensor
good
a very
or
huge quantity
will
of sensors.
be
So,
good to
the
use
idea is
in
to
the
try
project
to
for create the artifact.
platform for
So
this
these are
kind
two
of
cases
calibrations, because
that
we don't
we
do
explored
this
for IOOT
in common. Findings, some recommendations and future action. So this is very important for us because this is our experience. Maybe you can see this inside your labs. Findings, the principal findings are, well, currently a large number of low-cost sensors with good accuracy and stability characteristics are marketed. Each of these represent a challenge for the national metrology laboratories for the following reasons: different types of measurements, different buses for connection and sending of data. So we are talking about the different type of ways to connect and collect the data, different ways to integrate with a microcontroller or microprocessors. Each creator, the people who made the artifact, propose the best way for the desired purpose. Different ways of programming the device generate results and data with different formats according to the needs of the creator. Many times the information generated does not adhere to the CI or the international system. There may be a large amount of data, a large flow of information coming from the devices that the NMI cannot handle. Many times the large amount of information is not entirely useful for the calibration process. So must be discriminated, or we need to edit the information so we can lose some time editing this information. The NMI may not have adequate or complete capacity to cover all the needs of the Industry 4.0 in calibration. And this is real. This is something that that happened to us. The NMI's ability to respond to the needs of the Industry 4.0 can be very low, or the NMI might not have the resources for cover this need in the time that the industry needs. Some recommendations that we try to improve inside our labs: the NMI must have an area, department, or working group aimed to recognize the needs of the industry in terms of digitalization and metrology, as well as the new sensor used in the process. The NMI must develop new capabilities that allow it to incorporate calibration of few devices with with a particular characteristics or connections, programming, and information management. The NMI must have good communication with the client and with the creator of the process metrological solution to be it a measurement devices, an algorithm, and a programmed tool to ensure the validity of the data obtained. The NMI must not forget the traceability to SI unit, and this is fundamental to ensure the quality of the process, and the client must be aware of this aspect in the development of their process. The NMI can implement tools that allow it to improve this response capacity to the needs of the Industry 4.0, either to have more resources to cover the needs, or by linking this by linking with partners with demonstrated capacity with other interested parties for that can be collaborate and solve these needs. And our future action for this kind of situation is improve traceability capabilities as far as possible to cover the areas required by the industry, create an internal LNC network to integrate environmental condition sensors and remotely monitoring work areas and areas and laboratories, increase the participation of other companies that develop low-cost measurement equipment through the industrial linkage strategy, involve more technical staff in metrology for digital transformation activities to diversify the offer of external service. And finally, this is more commercial. This is a representation of our strategy, industrial linkage strategy, estrategia de vinculación industrial, that have three areas, three important areas. Technical accessory for the metrological industry, public and private alliance with some different institutions of the government or the private sector, and cooperation projects that allows us to try to increase our experience. The object of this is industrial linkage strategy is to strengthen the link between the LCM and the Costa Rican productive sector through an institutional positioning that responds to the metrological needs of the different levels of business that are developed in the country. Okay, this is what we try to explain to you. I hope you understand my poor English. Sorry for that, but thank you so much.
Thank you, Olman. You really have a very good English, and we understood everything. Thank you very much. So I don't know if you have questions for Olman, please. You can raise your hand, please, here in the Teams, or if you want, you can write your question in the chat, please. Feel free. In Spanish or in English. Don't worry about it. Meanwhile, I would like to ask something, Olman. How many people works in the project with this company, and if you collaborate with other institutions or other allies? Creo que no te escuchamos, Olman. Tienes apagado tu micrófono.
Okay, thank you. Yeah, thank you so much. In this project with Narime, worked 3 people. One in the humidity and temperature area for the measure of the temperature and humidity in air variables, and one for the measures made in the pressure area, and one for the administrative production for say something. So 3 people make this, but it's more complicated than that, because at the first moment we only received the sensors without nothing more. So this means we was to ask to the industry for the platform for connect the sensors and the software. In that moment, we start, or another people more, start to try to understand what was needed for integrate this instrument inside our chambers to calibrate that instrument. Was confused at the first moment, but we try to solve this in that moment.
Thank you, Olman. Thank you very much. I think it's the Metrology for Industry 4.0. I think it's a multidisciplinary work, and you have to have support for many areas of the NMI.
Mm-hmm.
We have one question in the chat from Gabriel Span. How do you imagine calibration of instruments that require comparisons with physical standards?
I try to understand the question. Okay, I try to explain what we solved the problem with the THB sensor for the IDV project. I think maybe this is a way to respond this question. We decided to create a prototype for this project because the idea is to create a prototype inside the lab to try to requires some information of calibration or variables like temperature, like pressure, or like humidity. So how we imagine that? We try to find a platform for connect these sensors, and I think in the future maybe happen this situation. I think to think in. I try to think in intelligent infrastructure, for example, or a building or something like that. We put a lot of sensors inside the building, and we try to know what is the building, what happened with the building. It's like to say what is the building sense. So in the future, we try to think in a very huge quantity of sensors inside the lab, changing changing the normal calibration that we do. In the future, we don't have one equipment compared with another equipment in a special area and special condition. No, maybe we think or we have a huge quantity of sensors and different platforms for put these sensors, compare the sensors with a standard, national standard or work standard, and try to figure out what is happening with these sensors. These sensors change. These sensors have the real information. These sensors are working or not, something like that. In this case, for the THB project, we think in that we try to know and learn how these sensors works, and put the sensors inside the chamber and try to experiment with the sensors what will be the future, what happened in the future. Right now, there are some labs inside the University of Costa Rica working with this, with different sensors, in trying to make some artifacts for low-cost artifacts that maybe solve some problems inside the industry or different areas, for example, agriculture or something like that.
Thank you very much, Olman. I hope you, Gabriel, Olman has answered your question. If not, Olman, I invite you to write your email in the chat because surely there are more doubts, questions, or somebody wants to make contact with you, feel free to contact Olman. Thank you very much, Olman. So let's.
You're welcome. Thank you.
Thank you, Olman. So let's continue with our next talk. The next talk is going presented by our colleague Marcos Eduardo Bierzichudek from INTI Argentina. And the name of his presentation is New Metrological Resources of Industry 4.0. Marcos Bierzichudek received the Electronic Engineering degree from the Universidad de Buenos Aires in 2006 and the PhD degree in engineering from the Instituto Tecnológico de Buenos Aires, Argentina, in year 2016. In 2005, he joined the Electricity Division of Instituto Nacional de Tecnología Industrial, INTI, the National Metrology Institute of Argentina. Mainly in his areas of expertise and interest are resistance and voltage metrology, width and cryogenic current comparator, low current and surge measurements, the control theory. His current research includes the design of electronic devices for high voltage and current metrology. Marcos collaborates on several joint research projects with institutes and companies from Argentina, North America, and Europe. Furthermore, he's teacher at the Universidad de Moreno since 2017. As well, as I said at the beginning, he's the coordinator of the task force of the Metrology for Industry 4.0 in the team working group 14. Welcome, Marcos, and the floor is yours. Go ahead.
Hello, could you hear me? I am presenting, I don't know if you can see it.
Yes, we can hear you and we can see your presentation. Go ahead.
So, thank you very much for this opportunity. My name is Marco Bierzichudek, and I am presenting a work titled New Metrological Result for Industry 4.0. The content of this presentation is the following. We have first a project overview, I will talk about the key point, the objective, the traceability chains. Then I will talk about the development and the result obtained until now. Specifically, I will talk about the digital calibration certificate, traceability, in vibration sensor, traceability in multifunction calibrators. These are the two areas where we are applying the digital calibration certificate, and finally the conclusion. So, which are the key points of the project? This is an associated research project funded by the Ministry of Science and Technology of Argentina. We have two partners, Hightech and INTI. Hightech is a private company of Argentina. They give a presentation in the last M4DT conference 2 or 3 weeks ago, I think. We are working with them in this project of 18 months. This project involved 18 professionals and a total budget of $335,000. The end of the project is in 2023. So, which are the objectives of the project? We have two primary objectives, and they are focused, of course, in the industry 4.0. What happened in the industry 4.0? We have a lot of different data, and we have to take care of the data. In particular, we are interested in the calibration data of the instrument. So for that, you know very well, there exists a lot of interest, international interest, to set up some digital calibration certificates. So the first objective of this project is to ensure the calibration data quality in its generation, the use, and in the transfer between the provider and the client. We apply the digital calibration certificate, and we will apply in two different areas. One is the vibration area, two sensors that are directly installed in a company, in an industry, and the other area is the electrical area, which we're going to be focused on the multifunction calibrators. This is the first objective. The second objective is to reduce the effort to obtain traceability. Nowadays, what we are interested in is that the client can reduce all the cost, the risk to obtain traceability. So the proposal is to bring the standard closer to the instrument under calibration. In this way, the laboratory that provides the service will assume the risk to move the equipment to the laboratory of the customer, and also will assume the dead time that means to move the equipment. So in this way, the customer don't need to lose time, don't have risk in the its standard. The price can be the same or higher, but what we are thinking is that some customer in Argentina has many instruments, many multifunction calibrators, for example. If you move just one standard, can be lower the final price of all the service, including, of course, the transport of the calibrators and instrument. So we're going to apply this in two traceability chains. The first chain, as I told you before, is the sensor applied to measure vibration in an industry. So for this, we're going to implement a digital traceability chain from the primary standard at INTI to the sensor produced by Hightech and installed in a company. The work involved a new standard at INTI and also all the procedure that Hightech requires for make the calibration of their products. This is a very interesting example of application of the DCC, because will be an application directly with the end point in a product applied in industry and for industrial IoT. So I will show you next that the DCC will be integrated in the software produced by Hightech. And we hope that this shows to the rest of the company that produce device of IoT or similar application that they can take advantage of the DCC. The other traceability chain where we are working is in electrical for multifunction calibrators. In this case, we are making a new process which is fully automatic to the calibration of multifunction calibrators. This system will be controlled by the software, and the software will read the DCC for the multimeter and also will generate the DCC for the calibrators. In this case, it's quite important, this example, because the calibrator needs more than 100 points of calibration. So the certificate used to be very large. And in this way, we are giving an example of another powerful application of the DCC, where you have very large certificates, calibration certificates. We are also interested in automatic multifunction calibrator because nowadays this process is semi-automatic here at INTI, and we believe that this can be also be applied in private laboratories. And nowadays in Argentina, we have just one laboratory that can perform this task. So we're interested to create more offer of this service. So, which are the development and results that we are obtaining until now? First, about the digital calibration certificate, we have a lot of different information about that. So I don't going to be to waste a lot of time speaking about the digital calibration certificate. Just a definition about it. It's a document that is transferable, accessible, secure, robust, interoperable, reusable, machine readable, capable of being understood by humans as well as machines, and capable of storing metadata like any other information. We are using the PTB format and in XML file. For example, this is the first page of an actual certificate generated by INTI, where we have all the information about the device under calibration, the dates, and the client, and also about INTI. So how we change this information to the PTB format or the XML file, just in this way. Each of these levels indicates some information. That level is defined by the PTB format. So, for example, postcode means the postcode of INTI in this case, and here we have the information in the middle of the two levels. This is also the is a typical file, XML file, but the name of the level was indicated by the PTB format. Here is an example of how we can express measurement results. Sorry, I have a problem here. For example, if we measure 1 meter of length, first we have to indicate the quantity type, the value, and the unit. And then I can indicate the uncertainty. This is the expanding uncertainty, and the coverage factor, and the type of distribution of the uncertainty. So this is the proof of concept that we are having nowadays at INTI. This is an online platform that is in a server here at INTI, and any metrology of INTI can use it by an Internet Explorer. You can download first the spreadsheets, and then you upload this spreadsheet to generate the XML file and the PDF file. This platform make both, generate both files. The spreadsheet you download are nowadays for 3 different types of calibration: the PT100, accelerometers, and multimeters. Why we do in this way? Because this is compatible with what we are working nowadays in the service. So the metrologist has to copy the measurement result in the spreadsheet, then upload the spreadsheet to this platform and generate the DCC. In this way, the metrologists don't need to take care about all the libraries, software that the platform requires. So for that reason, we use a server instead to make this like a program that runs in each computer. So the point is how we can apply the DCC from 2 traceability chain. And this is what we are talking about. And this is the first example. This is the vibration traceability chain. It starts in the primary laboratory of INTI with the primary standard. With this, we generate a DCC for the standard of the company High-Tech. Then High-Tech can calibrate its standard, its working standard, these calibrators, and then with this instrument they give value to the sensor that finally can be installed in a company. All the transfer of data is made with the DCC. So INTI can calibrate the High-Tech standard by interferometer method under the norm ISO 16063-11 method 1 and 2. In the frame of this project, one of the objectives is to update this system to a model system 1. INTI already implemented the digital calibration certificate for these accelerometers and calibrators. High-Tech calibrated the calibrator 9100 back-to-back by a back-to-back method. We select this instrument because it has an DNC output where we can measure directly the internal accelerometer signal. And High-Tech has a 6.5 digit multimeter for this task. So we don't calibrate just the calibrator. We calibrate the calibrator plus the multimeter. And then they have to use in this way because we make the calculation, and in this way we will reduce the uncertainty of the standard, and because we have neglected the uncertainty of the internal readout or the internal digitizer of the instrument. So, and then High-Tech wrote the calibration procedure for all this calibration, and now we already have an XML file for this shaker, this little calibrator. This just can work at 2 frequencies and can be used to perform in situ or remote calibration directly in the where the sensor is installed. High-Tech is working to modify all his software platform, in order to integrate the DCC. So when the data measured by the vibration sensor is analyzed, they take in consideration they can correct the data by the DCC, or they can calculate the uncertainty. So the other traceability chain where we are working is the electrical traceability chain. This is our objective is to create a new automatic system to the calibration of multifunction calibrator. In the signal that you can see here, the magnitude is DC and AC voltage, DC and AC current, resistance, capacitance, and frequency. With this range, as you can see in the AC voltage, we don't try to cover all the range of the multifunction calibrator. We work in the reduced range, but this range is the most important for the industry. So the new system is quite simple. It is based in a high accuracy multimeter and state-of-art multimeter, and custom-made multiplexer. We call a multivariable multiplexer. And with these 2 instruments, we plan to calibrate the multifunction calibrator. Nowadays, to make this task, we use all these other instruments. We use a high accuracy multimeter, an LCR meter, an AC voltimeter, a lot of different resistors and shunts, and a lot of different cables and adapters. So why we try to modify this system? First, because this, as you can see here, is semi-automatic. You have to be changing between different instruments. And second, specifically the AC voltimeter is a very expensive instrument, very expensive calibration, and it's quite difficult to think that that the private company in Argentina buy one of these instruments to calibrate the multifunction calibrator, because it's extremely expensive. So for that reason, we are trying to make this automatic, simplified system that can be useful to perform the calibration and can be interested for private company in order to give this service with a reduced range, of course. And another advantage of the new system is that it is a transportable calibration system. It's completely impossible to move the other the actual system to a customer lab is a lot of instruments, but these two instruments are very simple to transport. I have to be clear that some resistors are included in the multiplexer box. So in a sense, we are eliminated the LCR meter, we are eliminated the AC voltage, which is the AC voltmeter, which is a more expensive device, and we don't use all the resistors that nowadays are using. In this way, we can implement the remote calibration. This means to carry the standard directly to the laboratory lab, and the metrologist can be in his lab working and controlling the measurement remotely by internet. So since the system is quite simple to use, the idea is that the customer can make the connection and then everything run with the software or can be controlled remotely. So we are building now the multiplexer, multivariable multiplexer, and these are the specifications, the objective of the specification. It has an isolation resistance larger than 1 teraohm. This is important because we are measuring resistance up to 1 kiloohm, and to obtain an uncertainty of 0.1%, which is enough for this application, we need an isolation resistance in the board and relay of 1 teraohm. Then we need a thermoelectric voltage lower than 0.1 microvolt. This also is important to obtain a 1 ppm uncertainty 100 millivolt at DC. I have to be clear, 1 ppm is stable measurement because we are going to make a zero of the measurement. So this is the variation has to be lower than 0.1 microvolt. Then the contact resistance of the relay has to be lower than 1 ohm. This is important because when you measure AC voltage, the strike capacitance of the digitizer can generate some voltage divider, impedance divider between the wire and contact resistance and the input capacitance, and making all simulation. If you have lower than 1 ohm, you have 10 ppm at 20 kilohertz. 10 ppm for this application is very good. The strike capacitance has to be lower than 5 picofarad, and the maximum voltage is 1000 volt RMS and 20 amps RMS. This is the circuit schematic. We are using the front and the rear panel of the multiplexer. The front panel are used to measure current. The rear panel are used to measure all the other magnitudes. And we are using some internal resistor of the multiplexer in order to improve the uncertainty in current. These are the board that we are already finished. This is a digital board that was produced by Hightech. And here you can see all the analog, the opto isolator, the temperature sensor, and it is connected by USB to the computer. And this is the current board that you can see that it don't have component because we had a lot of products to buy the component. We need like 4 months to buy some relay. Already we have there. This is a crazy moment to buy component, international component of accuracy, because you can't find market international. And the interesting point of this board is that the shunt is directly connected by this plug in the board. We have space to 2 shunts. These are the shunts for 0.1 ampere, for example. And then here we can connect another shunt of larger current in separate way. Also here we have the possibility to connect another shunt. So inside the same chassis, we can leave the shunt there installed. We already could test one of the board. This is the multivariable board. This board will be used for voltage, voltage resistance, capacitance, and frequency. We test it using a Fluke 5700 calibrator and a HP 7458 multimeter, and we obtained this error. This was a test under the table. The error with and without the board was in DC voltage was lower than 1 ppm, in AC voltage up to 20 kilohertz was lower than 25 pico ppm, and in resistance in all the scale was lower than 5 ppm. This is from 1 ohm up to 1 ohm. We expect to have better result even when we have the final system installed. This is the thermoelectrical voltage of the relay that you see previously. This is a very nice picture. You have all the measurement here in the horizontal X. In the left, you have the contact voltage. In the right, the temperature. The green line is the temperature. So we're going to, you're going to see how the temperature was changed in the board, in the climate chamber, and then how in blue, the thermoelectric voltage of one way of the board was lower always than 0.15 microvolt. The peak that you can see coincides with change of the temperature, and this is produced because the gradient on the board increased the thermoelectrical voltage. So with this measurement, we can be sure that the specification of a low thermoelectrical voltage will be obtained if we want to maintain the temperature almost constant in the board. So the board will be integrated to a software. This is a software that actually is using to calibrate this type of instrument, and it was already updated to control the multiplexer by USB port. You select the instrument to be calibrated, the instrument to the calibrator. You can select the address of both instruments and put some information about the service itself. Then you can select what type of service are you interested to do. And finally, you run the program and you start to see in this spreadsheet all the information. So what we need to do now is to update this system to perform the calculation and then generate the GCC. Tonight, if you calibrate the multimeter with this system, you need to then pass the copy the result by hand in the spreadsheet generated by the platform, but the idea is to make this process automatically. So my conclusion, now finishing, sorry, okay. The digital calibration certificate platform was implemented. It is almost 90% make, and I think that in this beta version will be for a lot of time. Then the partners are working to establish a digital traceability chain from the primary standard up to the vibration sensor. We are now in a very good process to finish this in the 2023, and we are making the fully automatic system to calibrate multifunction calibrator. The multiplex is under construction. We already have the procedure, and the software is almost done. So we also believe that in 2023 we're going to be finished this part of the process also. So thank you very much for your time.
Thank you very much to you, Marcos, for a very interesting project that you are working. I invite you to do your question in the chat, or if you prefer, you can raise your hand and use your micro. You can feel free to speak in English, to speak in Spanish, please. In the meantime, maybe you mentioned, Marcos, but I don't know if the project allows you to calibrate different models of accelerators or a specific model. I don't remember if you mentioned.
No, when we prepare the DCC, is we try to be general for each type of instrument. It's quite difficult, and this is the problem that when we make the DCC, because everything has to be quite standardized. Okay, so the points, the information you give, everything has to be fixed. But what we're trying to do is to think in type of instrument instead of just one model.
Okay, thank you, Marcos. So, any questions?
So, yes, I have a question.
Okay.
I'm Jackson from Brazil. Okay, can you hear me?
Yes.
Yeah.
Yes.
Yes.
Go ahead.
Yes. The intention is to make another service to like a contract of calibration with companies. Yes, that's what I understand. Make contracts of calibration for companies to make a solution to a company and then make the calibration. And could be starting with accelerators, then perhaps pressure calibrators and so on.
Yeah, the first objective of the project is to have some example of application of DCC. This is the first point. And then for example, the traceability in vibration, what we are thinking is that the company has the possibility also to make all the traceability, internal traceability, to the product that they sell and install. So up to now, we are just focusing these two areas, vibration and electrical, special multifunction calibrator or multimeters. But of course, the DCC in one moment can be synced for any other type of instrument. And in this case, the spreadsheet and the software had to be rewriting for this type of thing. So what we are seeking in the DCC, we are not seeking to apply in all the service of Indy. We are just seeking to apply in the service where we require that. This is because you have a software that can be used, the DCC, or because we have plenty of data to transfer between the customers and the provider, service provider. Okay, I was clear?
Yes.
We are not seeking to apply in all the service of Indy. We are just seeking to apply in the service where we require that.
Can you share the
This is
presentation?
because
Yes,
you have
I
a
think
software
the
that can be
presentation
used.
they're going to be available in our web page. So just wait after this event, please. Thank you very much, Marcos.
You're welcome. See you.
See you. And let's continue with our next presentation. Our next presentation tries to include some of the key issues to take into account in a strategy to implement metrology for Industry 4.0. In the task force, Metrology for Industry 4.0 have been working with our colleagues from the SIM, and we are trying to do a guide or compendium of experiences, capabilities, as well as recommendations in order to maybe have a strategy or a pathway to get to reach to metrology for Industry 4.0. So the next presentation is going to talk about it, and our next presenter is our colleague from Senam, Mexico. The title of this presentation is a strategy for the implementation of Industry 4.0 by Aldo Garcia from Senam. And Aldo Garcia has experience in development of projects and services for the area of vibration and acoustics of Senam, knowledge applied to vibration and acoustic measurement, experience in calibration services, development and optimization of measurement systems using instrumentation and signal control of various transducers, as well as programming skills, knowledge of standards for measurement laboratories, uncertainty estimation, teamwork, continuous improvement, and implementation of agile models. He has an active participation in digital transformation topics such as Industry 4.0, Metrology 4.0, digital calibration certificates, remote sensors, and metrological cloud. He currently leads one of the digital transformation task force under the name of Agile Project. So welcome, Aldo. I'm going to participate with him in the presentation, but Aldo, please start and go ahead with the presentation.
Thank you very much, Gabriel. Thank you for all of our participants here in this meeting. As Gabriel said, I'm going to talk about a strategy for the implementation of Industry 4.0 or zero through digital transformation. And this topic is very interesting because, as Gabriel says, we developed this presentation with all our experience and And we want to begin this meeting and this talk with this slide, because we want to let you know which is the digital transformation goal, and understand the process to achieve the digital transformation. This is very important, because if we want to impact to the Industry 4.0, we need to pass through these different stages of digitalization. So you can see we initialize in our NMIs. We need to make a scope of which stage in which stage is our NMI. So we start from the digitize information. Is only put the information in a digital way. We are not using it for any process. It's only for storage of information. Then we use the digitalization to integrate this in a process. So maybe we can see here this first stage of digitization, like the PDF, digital calibration certificate. But if we are going to use to the next step of digitalization, maybe we are thinking in another kind of focus, like use the information between computers to introduce this information in a process. So this is the automate process and stamp line processes. We need to use digitalize data in order to put into a process and take advantage of this information that is stored in our databases. So the next step is the digital transformation, and in here we communicate not only processes, we are communicating organizations, we are communicating different product lines, we are communicating a lot of information through different stages in the organizations and between organizations. So in this final step, we see the true shape of the digital transformation opportunities. So we need to understand if we are an enterprise organization or an NMI, we need to know very well in which stage we are. So this is an explanation of the different stages that we are thinking on, and in which we are. We need to know in which we are. Sorry. So regarding the metrology, we thought this is a good way to express in a sentence the digital transformation in metrology. So we say that it's the usage of computers, instruments, IT technologies to automate and optimize a process through the exchange of standardized data between machines in order to give traceability among the metrology value chain. So you know, this is we mix different definitions of digital transformation, of metrology, and we converge those ideas in a few words. So if you can see here, I am showing you how is this process, how we use the traceability, and how we are going to use meta languages to use this information, not only to storage. We need to share the information between organizations. So we need to pass through this firewall, if you want to make an analogy, firewall between the NMI of secondary laboratory or so on, the people that are given the traceability from calibrations to our users, final users, can be the industry, for example, or the government, and there is a lot of possibilities here. So we need to share this information to be used in different process. So this is why we need to digitalize the systems, because we need to share this information. We need also to talk one only language, or make the effort to give this information in only one or kind of language, because if we want to take advantage of this interaction between processes and organizations, we need to talk one language. So that's why meta languages can be this answer. So if you can see in a transversal way, we have the digital transformation. So this is in order to let you know and you focus your effort to understand our vision of how is the digital transformation in metrology. So we are thinking in take we need to define the strategy. So that's why we are agree. We're thinking that is a good way to share information in a standardized way from the use of the XML for digital calibration certificates. And we want to share with you this slide that is comes from the PTV, only to let you know the different levels that are included to have the utility model of the digital transformation using the DCC. So the first stage, as you know, is the paper. We use the paper to communicate, to inform, to let the user the information about the calibration, and this was useful for them, maybe for accreditation topics or something like that, but not for maybe for introduce it to a very complex system to be, because it's not the timing is different, so there is no real time in the sharing of the information. So that's why some industries are still doing this in this level. And then we go to the digital document. As this is a PDF only for let the user to share the information to the user and maybe storage the information. The level 2 is machine readable document. So here we can share between machines the information, but at the level 3, the machine can make some processes, very basic processes, like understand the information, maybe extract some kind of information. But in the level 4, we are interpreting the information. We have good practices there, and we can be more flexible about the uses of this information to impact different processes and or organizations. And the final one is the machine controllable contents. We are saying about digital twins or applying intelligent artificial intelligence. Maybe we want to read different documents and extract information and have a better way to use this information in a very automated way. So the level 5 is our goal. So this is important to you know this, because we think this is the proper way to do it. As a personal comment, for sure. And here I'm going to give the word to our colleague Gabriel. Please, Gabriel.
Thank you, Aldo. Yes, as I mentioned before, the idea of this presentation is to show, to put for your consideration this steps of the strategy. We call the strategy, but we are building these steps in order to get the implementation of the metrology for Industry 4.0. We already know that in general terms, the Industry 4.0 use many tools, technology tools, and there is a tool that integrate the different key topics, and there are many tools. I show in this slide just one that was performed in Germany. But the idea is, but when you see this type of tools, you don't see metrology. So as you can see in this general self-check for Industry 4.0, they talk about employees, strategy and organization, smart factory, where the metrology is included, but not explicit. the smart operation, smart products, and data-driven services, and then other subtopics. And then this tool in particular, it depends of the auto evaluation, identify if the industry is in newcomer, learner, or leaders. So the idea is as well for the next step, next slide, please. In the task force, we develop a simple Excel file in order to know where is our NMI or lab on the road to the metrology for Industry 4.0. So the idea is where we are and to make about the diagnostic we consider 11 key elements. One of them is that the NMI of lab has a M4DT strategy. The other one, and some of them has mentioned by our previous colleagues. I remember that Noldman mentioned that the LCN has a structure that has personal, but it's very necessary to have a different kind of expertises. So the organizational structure, as well, the automated processes is another key element. Marcos mentioned the DCC, Digital Calibration Certificate, is one is the ideal capability in order to introduce to Industry 4.0, as well as cybersecurity, the communication is very important as well. The systems and programs is another key element. The use of the cloud, to use a cloud computing, and other key element that we consider in this tool is the consulting to industry. As Norman mentioned, that they have this industrial linkage strategy in order to get closer with the industry. The other key element is that we already have clients, customers for Industry 4.0 in order to make or to do new services that attend the needs of the industry. And the other is the technology as well. The phone, in the case of example that Marcos showed us, but he mentioned that the project was founded by other institutions. Okay. Next one, please, Aldo. Is your turn. Go ahead.
Yeah, thank you. Yes, it's very important, the comments that Gabriel gave us. So that's why we are suggesting to implement a TRL plus digital transformation surveys or analysis in order to implement the metrology for Industry 4.0. So we can see this a very typical or general TRL, that is technological readiness level. So there are nine stages. Maybe you can understand this if I can explain it further, this information. So in the stage 0, we have the first principles. We are going to define in our NMI which is the strategy that we are going to implement in order to achieve the Industry 4.0. So if you can see in the right side of the slide, I place a very complex, if you can see, diagram in order to explain better these ideas. This is because you can see different colors, and we are trying to explain the different stages to understand if the NMI can be prepared or can participate in order to have this interaction with the Industry 4.0. So the first thing that we suggest, I'm going to explain this first, and then I'm going to relate the TRL structure, is we are going to reunite with our NMI. We know that our core is at metrology. Our core of the NMIs are metrology. We know very well that we need to implement another kind of skills like programming and developing of electronical devices and so on. but our core of the NMI is metrology. So we need to take advantage of this. We need to have a reunion with our NMI directors, and we need to understand and make the question, what is the Industry 4.0 for our NMI? We need to answer this question first. Then we need to ask to the different areas or departments or silos of NMI, for example, mechanics, electric, materials, chemistry, physics. Those different areas, we need to ask them their capabilities and the services that they are providing, and if they are interested in collaborate to develop a tool or develop a solution that can be impacted in the Industry 4.0. So those different areas need to understand, need to share this information. For example, the different departments from, for example, mechanics. This is an example. Maybe Dimensional wants to share something to impact to the Industry 4.0. Maybe they have a methodology, developed methodology, a test bench to impact in the industry. So first, every time I want to say it, first is the metrological core. Here is only metrological core. So then in this step, when every area has identified the capabilities or services that can be impact to the Industry 4.0, we are going to have this interaction with a task force in the NMI. Maybe you are achieving the goals to develop digital transformation in your NMI. So we need to merge the core of metrology and the core of digital transformation, and they are going to collaborate. So first, we identify the capabilities of every area to impact at metrology Industry 4.0. And then we are going to go with the digital transformation team in order to add this other kind of skills like programming and developing of electronical devices and so on, integration. And in this way, we are going to complete this synergy between the core of metrology and the digital transformation. And we are going to prepare a user case. We need to prepare a user case. We need to invest in order to develop a solution that can impact to the Industry 4.0. So then we are going to select this. For example, we select one capability from temperature, and we are thinking to impact to the industry, maybe in a thermographic chamber. And in this way, we are going to have an implementation to the temperature laboratory. Here we are going to share, and we are going to share the information maybe between digital calibration certificates, maybe giving them the solution, applying methodology, and always merging the core of metrology and the digital transformation. And in this way, we are thinking that we can impact to the Industry 4.0 in a very well-known form to implement our core, metrological core, with the digital transformation core. So we need to implement these different stages of the TRL in order to implement and deploy these different capabilities from our metrology course and areas. So this is a pathway to implement M4I 4.0 that our colleague Gabriel going to explain. Go ahead, please, Gabriel.
Thank you. I think there's nothing more to explain. This is a summary that you already said. So please, I suggest to change the slide, please. The next one, this slide tries to show maybe the type of approaching. As you said, Aldo, there are a way to do in order to implement in the NMI Metrology for Industry 4.0. In this slide, in the left side, there are some activities, functions that that are in red, that it can be our strengths, because there are activities or technologies that we already, most of the NMIs have. So in the yellow letters are the activities that are implementing already. As well, some of them are mentioned in this event, and the other ones are in the green color are the activities and technologies that the NMI has to implement in the near future. As well, we have to know our strengths, our weaknesses, but as well is very important to be very close to the industry 4.0 and to know what they are doing now. In the case of the side, in the right side, some of activities that already do the industry, but it's automation like SCADA, for example. They have a sensor network. They did 3D manufacturing, robots and cobots, digital twins, and they are going to advance and sustainable manufacturing, and as well as Olman said at the beginning, to work in the internet industrial of the things, as well cybersecurity, big data, and then machine learning and augmented reality. The idea is to, as a NMI, to be aligned to know those kind of needs in order to meet the digital needs and challenges. And we know that all of our NMIs and labs and bureaus has industry to services to industry, some technical assistance services like Foreman said that they have a heavy tool. In Mexico, we have a Mesura, and we are trying to to improve our methodology in order to to meet the digital needs to the industry, as well as well as Marcos mentioned, it's very necessary to have a strategic alliances to make that kind of alliances, and as well projects and close collaboration, win to win and learn to learn. And Mexico, we have one project as well as the DCC with automotive industry. The idea is to work in both sides, push by the NMI with our expertise, our capabilities, and our offer. And the other side is to take into account and to attend the industry, what the industry is interested in metrology. So this is more or less one idea of this approaching to Industry 4.0, seen from the metrology. Next one, please. Some concluding remarks. I don't know if you want to mention, Aldo, please.
Yes, thank you. The final conclusions are that we need to share NMI experiences, capabilities, and learnings in Industry 4.0. We need to merge different skills. That's why we say that it's a multidisciplinary development. We need to focus on developments that can be replicated to more services and not just to one. This is a very important thing. Focus on services that can impact users and explore different types of industry, agro, food, pharma, energy, and so on. And we need to close collaboration with communications and information technologies to developers and SMEs. Yeah.
Small and medium enterprises.
Yes. Okay. So thank you very much for my side, and I for sure from the side of
Thank you.
Gabriel for this time. And if you have some questions and comments, suggestions, please let us know. Thank you.
Thank you very much, Aldo. And we have a question, and Roberto Benitez, please go ahead with your question, comment, please. We can hear you. Okay, go ahead.
Hello, how are
Thank
you? I have
Very
a
good.
question regarding to the work that, in this case, Senam is doing in a digitalization. From your point of view, what do you know, or what do you consider is the final user of the digital calibration certificates? Would be the plant or the industry that is on the field, or the secondary laboratories? Because as I know, the final process of the calibration is the instrument that is installed in the process or in the final measurements. What will be your customers, like an NMI, the industry or the secondary laboratories?
Go ahead, Aldo.
Yeah, thank you. For sure, we are giving the usage of the DCC not only for industry, not only for laboratories, secondary laboratories. They are open to those that needs to use this digital calibration certificate information into their process. We are seeing that for sure in more or less 2 or 3 years, the secondary laboratories must to go through the digital transformation topics and developments in order to implement digital calibration certificates, because we are seeing and we are advising that in some few years the industry and the government and so on will need this kind of information to put it in their processes. Right now, maybe it's not a necessity because we are developing right now this. We are in how do you say? We are in parallel with our colleagues in Europe developing this digital calibration certificate. So that's why we are seeing that in 2 or 3 years we are going to need to spread this DCC to our users, like secondary laboratories, in industry, government, different economical activities. So that's the answer. I don't know, Gabriel, if you want to say something else.
Thank you, Aldo. Yes, me note what the Carlos Galvan, our colleague Carlos Galvan, has write in the chat that DCC user, as well as for industry, is for all entities in the quality infrastructure. So I don't know if Marcos Verstude would like to comment something.
Yes, hello, how are you? It's difficult, I think, trying to understand the final impact of the DCC. We are discussing here a lot about that. Some way I think that it will be very interesting in some applications. In others, I think that perhaps not. This is my interpretation now. So I don't really believe that we have to be implementing the DCC. We have to, as recently say, to see that this is something that is in process, that will need some time to reach a stable state. And we have to start to show experience and apply the DCC where we really believe that it's important. For example, when you have a lot of data, of calibration data. In that case, it's very important. And in that case, we have a trend that is useful right now, nowadays, which is the calibration of the vector network analyzer. They produce, it's not a DCC format like PTV, this format was produced by Metas of Switzerland, and this is a format that is used here at India and many other countries. And the great advantage of this is that the Metas also develops a software to understand the XML file and calculate all the uncertainty for the use of the vector network analyzer. That is an example of something really useful, but I don't know if we're going to have this experience in the same way in all the areas. I really believe that the DCC will start to be useful and very useful in some application. A lot of data. Oh, yes.
No, go ahead. Go ahead.
No. I think that there are two areas, or a lot of data, or where you have a software that control all the process, no, like in IoT. No more.
Thank you, Marco. I'm going to just clarify that yes, it's important your comments, and that's why we said in this presentation that the NMI must define. In these slides, we are showing about the Industry 4.0 and our suggestion. This is a work in progress, as Gabriel said, and that's why each NMI must to meet with the different areas inside of those NMIs and discuss in that moment for them, in that case for the DCC, what is the goal of the DCC. And I think you made this analysis with your NMI. That's great, and that is a very big step that most of the NMIs must take. Understand which is the path of the NMI regarding for that case the DCC. In this case, is the Industry 4.0. Yes, and that's why we understand that maybe these are different scope right now regarding those topics. But you can see each NMI must have these meetings in order to define which is the path that they are going to go through, and this is because they have different industry situation, different economical situation, different political situations. So that's why each NMI must converge in a meeting to discuss these topics. This is only to go with the analogic part of this presentation. I don't know, Gabriel, if we have another question or time, or if you have some comment.
No, I don't know if Carlos Galvan, would you like to add something, Carlos? Feel free to speak. Yes, go ahead. Yes.
Thank you.
Thank you, Carlos. Thank you.
Okay.
Thank
you, Aldo.
Robert.
Thank you, Gabriel. Thank you for your information. That's all
Thank
for me.
you,
Thank you.
Roberto. Thank you very much. So let's continue with the event. And as I said at the beginning, a brief survey will appear in the chat. I invite you to answer the few questions, please. While the survey is being completed, I would like to take this opportunity to invite you all to visit our website, where you will find more information as well as a preview of presentations and recordings of past events. Thank you all, and especially Olman Ramos, Marcos Viespichudek, Aldo Garcia, for your excellent presentation and for sharing your knowledge, your experience on these interesting topics. Finally, I invite you all to turn your cameras so we can make a capture of the screen. We would like to have your faces, of the event. So we invite you to all turn on your cameras and we can make the capture of screen. And I hope Francisco is going to tell us the time when we can. Yes, Francisco?
Yes, of course. Thank you very
Okay.
much for joining this session. And we would like to cut all the cams that it could be possible and available. Then we are more than 15 people here. Then we want to take a picture of all of us. Please turn your cams on. I'm going to wait a little in order to have more pictures. Thank you very much. I think that we can join more people. Just a minute, please. Okay, a little more. I think that there are some cams off. Please turn them on. Okay, just a moment. Okay, I'm going to take one of the pictures. And I need to take another picture more, please. Could you wait a moment and turn your cams on, please? Okay, please say yes. Thank you. That's all. Thank you, Gabriel.
Thank you very much to all. Thank you for your participation, and we hope you join us in our next events, our M4DT days, our M4DT conference, and all the events that seen through the M4, through the Metrology Working Group of Digital Transformation. Thank you very much. Have a nice day.
And please remember to fill out the form in our
yes.
survey.
Please. The survey is in the chat, please.
Okay, thank you.
Thank you.
Bueno, chao, hasta luego.
Nice to see you.
Take care, compañeros.
Take care. Bye. See you, Javier. Bye.
Gracias. Saludos a todos.
See you in a couple of weeks over here.
See you, Javier.
See you.
Thank you.
Bye-bye.
Bye.
See you, everyone. Muchas gracias, compañeros. Excelente apoyo de Francisco, Carlos, Rubén. Muchas gracias. Claro. Muchas gracias, Carlos.
otro año, me imagino.
Pues yo creo que sí, aunque hay muchos eventos todavía aquí presenciales, ¿no? Esperemos vernos por allá.
Ah, no, los presenciales sí.